In this section, last section of chapter 4, I will give an approximation of definite integrals using two methods. These are all methods to give an approximation for definite integral, or normally if the function is positive, surface area under curve. One of them is the trapezoidal method. It's based on trapezoids. This is linear, and the other one is Simpson method, and this one is quadratic. We give approximation here with linear function. This one with quadratic function. Let me now remind you for trapezoidal method. If you have trapezoid, so the base is this one. This is usually the width, okay? The width. And this is the function. Just imagine the height is the function, if you remember. It's like if you have a linear function and you want to compute surface area under the curve. So if I have linear, I want to compute, that's exactly trapezoid. What will be the trapezoid? So is this height, okay? And this one, this height, I'm gonna call it H1, H2, and this one is delta X usually, which is the base. Now, if you want this surface area, you can cut here. If you cut here, it will be PH2 minus H1, and you add this one. Anyway, if you do the computation, if you compute this one, you will find something like the area is H1 plus H2, the average times the base. Okay. Now, what happens if we have now a function? This one will be f of xi minus 1. This is f of xi over delta x. Okay. It will be exactly, this one usually is delta x, and this one is f of xi minus 1. This one is f of xi. So what happened now? The area will be f of xi minus 1 plus f of xi times delta x. And what is delta x? Usually is p minus a over a. Let me just show you this one, p minus a over a. Okay, now if you take function, if you take any function, okay, let's say this is the function, whatever, okay, and what you do, you take simple division, all the way. Last one, this one should be A. So we A, and this one should be B. Last one, okay. Now where is the trapezoid? Trapezoid is this one. In general is this one. This one is almost linear here. Okay, I'm gonna give in this one seems the area will be this, the area of this. Trapezoids. If you add this thing up, you will get like this one. What is this one? This one is f of x1 for f of a, and this one is times delta x. This one is p minus a over n. Okay, now what happened here? If I keep adding them up, I will get something like this. So the first one will be f of x, all of them is p minus a over n. And notice this one is the same. So then I have just to do f of x0 plus f of x1 over 2 plus b minus a over n. Second one is here actually. It will be this one. If you notice second one, this is x2. It will be this is f of x2. And you keep going all the way. The general case is this one. This one is, so you will go and you keep doing this all the way to okay, you can see that these two can come outside. F of x and f of x1 is 2f of x1, etc. And this one, then f of x2, this f of x2 will repeat. So it will, so the 2, we will carry 2 all the way to xn minus 1. So this one, the only one that has coefficient 1 is this one, f of a and f of b. Okay. So now if you do the math, you will get, so Here I have to place 2 plus 2 plus 2 plus f of b. Okay, so this one is fairly easy. If you give subdivision, say, so and that's exactly is approximately the area from A to B of x dx. Okay, like for instance, if n is 4, what we will get? If n is 4, I will have subdivision of 4. Okay, 1/4, 2/4, 3/4. It will be A over 4, etc. Anyway, it will be like this. So if you do if we add them up, it will be about b minus a over 8. Okay, 2n equals 4, f of a plus f of x1 times 2 plus 2 times f of x2 plus 2 times f of x3 plus f of b. For usually the homeworks they deal with 4, so a to b. Okay, now I will give you an example with sin x. So if we have sin x, okay, if I want sin x from, let's say, use the trapezoidal to approximate integral from 0 to pi sin x dx. Okay, so what do we have here? We have, if we divide using n equals 4 subdivisions. So what do we have? From 0 to pi, sin x looks like this. Okay, say this is 0, this is pi. If I divide pi by 4, what will I get? Pi over 4? 2 pi over 4, which is pi 2, and 3 pi over 4. And this is 4 pi over 4, okay? Now what will I get? Okay, So what are the trap? They are here. See, this is one. Here is another one. Okay, and this one, and here is another one. I hide in here, and here is last one will be here. Okay, so then you have just to compute surface area of this. Okay, what do I have? So I'm not gonna do it again, but you can compute this one. But if you do the math from what you will get, this one is approximately pi over 8. Okay, so what do I have here? I have 0. This is x0, sine of 0. What did we say? F of 0 plus 2f of x1. Okay, that's the formula. What is f? F is sine, x1 is pi over 4. This should be x1. This is x2. This is x3. This is x0, which is a. And this is x4, which is b. Last one. So then you will get pi over 8 . Okay, this one is about, if you compute pi over 8, this is pi because this is 1, this is the root of 2 over 2. Okay, root of 2 over 2. Okay, if you do the math, this is about 1.896. Okay, but if you increase the subdivision, of course, this for n is 4, you will get 1.96. For n is 8, if I increase the subdivision, I will get 1.974, which is not too bad. Actually, what is the exact if you remember from the fundamental theory of calculus, I need to find antiderivative. Is minus cosine x, okay? Thus, if you remember, this is f of x, which is minus cosine x, which is minus cosine pi minus cosine z, which is 1. This one is 1. This one is negative 1 plus 1, which is 2. You can see, but what did we get for if n is 8? The area is about 1.974. It's almost 2, okay? So this is the exact surface area, which is 2. So if you, in reality, if you take sine x from 0 to pi, this one, the area here is 2. But if you use trapezoid method, it will be very close to 2. Yeah, okay. So this one is fairly easy, and they call it linear approximation. Now let's go to Simpson's method. Mr. Simpson. All right. I don't want to go through the details of method or Simpson rule or method. So it was invented by Thomas, introduced by the named after English mathematician Simpson, Thomas Simpson. It's already in 1710, can you imagine? 1710, 1761, the British were thinking about this method. Why this method actually? Where does this idea come from? The idea comes from this, the following. So if you take a polynomial of the form ax squared plus bx plus c, just imagine this is second degree polynomial or quadratic. Now we want to compute, if you have a quadratic function and you want to compute surface area under curve, what Simpson found, if you have the area, he found formula like this. He found that integral of a to b, this formula. I'm gonna call this one p of x, polynomial. This is same p minus a over 6 P of A. This is P of K. So this is P of B plus 4 plus P of B. It's a very nice formula. Actually, you can check it as a homework if you want. That's true for polynomial. Okay, if you take any degree 2, let's say x squared, if this is x squared, you just take a squared, b squared, and 4 times a plus b over 2 squared. Now what you can do, now if you have a function, you just, if you have some function, weird function here, you just take the approximation with the polynomial. Let's say the function is here, you take the approximation with the polynomial, and respect here, instead of 2, we'll have a 4. Okay, we can do the same. Now if you do, now we use what we use, the idea again. You have a function like this, whatever, then you use between, you take an approximation, so this is the subdivision, obviously, x1, xi minus 1, xi, etc., okay, all the way to xn. So here you're going to use, this is f of x, okay? And now over this interval, I'm going to use an approximation with what? With polynomial of degree 2. Okay, so f of x. So now what we have, the area under curve of the function is very similar to this one. So the area of a to b f of x dx is actually over xi minus 1 xi is same as which is the same as we said as the formula given before, okay, is the same as xi. Let me write it here. Because we gave the approximation, this is not trapezoid, it's not linear, it's what? Pxi minus 1 plus xi over 2 plus p over xi. Now we just add them up. We keep adding up this approximations, okay, of these linear functions. Then we will get what we get, and this is exactly the idea. So, for instance, if you take from x0 to x2, just imagine when I go, this one is about from x0 to x2 of p over tx. Okay, now let's say the formula, let's say you, but it has to be even, by the way, n has to be even in this case, then I will get will be x2 minus x naught over 6 times p of x naught plus 4p over x naught plus p over x2. Okay? And this one is like 2 times 3 or 3 times 2. So the formula will be, so is about okay. Because this one is about p of x1, okay? This like the average. We can consider the average like p of x1. Then we will get this for, and you can keep repeating this one and on. So then you will get, I'm not gonna go through to the details, but the Simpson's method, it tells you the following: if n and even, okay. If continuous, of course, on certain interval AB, then you will have the approximation integral of a to b f of x dx is about b minus a over 3n, and you start off f of x0 f of a plus, and the pattern is 4. Yeah, we have to use another color here. 4 f of x1 plus what? So if you do the math, 2 f of x2 plus 4 f of x3 then you repeat it again, okay? You repeat 4 to 4, 4 to 4. You go all the way to plus, but before last one has to be f of b. And this one is 4 f of x and minus 1. You have to be careful here. You must end up with this one and start with this one. Okay, the pattern that repeats is 4 to 4. Now let's say for n is 4, for instance, which is the common case, what we will get p over a over 3 times 4 over 12. F of a plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 and stop. It will be okay. Let's say you have sine, you will get from 0 to pi, you will get the same as we did previously. say sine. Let's say, for instance, I want to compute this one for sine. I want to use, I'm gonna do it just for sine again, use Simpson's rule or method to approximate integral from 0 to pi sine x dx. Yeah, if you remember, with n equals 4 subdivisions. Yeah, again, let me repeat the subdivision. It looks like this. So sine is like this. Okay, I will get 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now, if you go all the way, so what will I get? This is x naught for a, x1, x2, x3. Okay, what did we say? The 4-2 pattern will repeat. So I will get, what is the formula actually? P, if you remember, for n equals 4 is P minus A over n over 12. Okay, is like what we repeat is 1, 4, 2, 4, 1. That's the pen. For the trapezoid is 2, 2, 2. For the Simpson is 4, 2, 4. Now what will I get? P is pi. This is 0. I will get pi over 12. X1 plus plus 4 sine of 3 pi over 4 plus sine of pi. Okay, so that's the integral. And look at this one, is very neat. It will give you 2.005. And you can see, so the integral from a from 0 to pi of sine x dx is about 2.005. And that's using Simpson. And this one is much better than trapezoidal method. If you remember, trapezoidal method gave us 1/8. That gives 1/8.9. So this one is Simpson give us this one, trapezoidal give us this one. So I think the reason why, but remember the surface area here exactly is 2. Both of them are just some approximations, but this one is better. We can see already for n equals 4, n is small, is very good approximation. That suggests that sine x is almost quadratic on 0 pi, is about it looks like quadratic function. That's why the approximation with quadratic is much better than linear. If you take lines here, this one is much better actually. Okay, thank you, and that's it for today. See you next time.